So hello everyone, welcome back. So in this video, we are going to understand the Leetcode problem number 1674. So this problem looks very interesting because the question saying that we have to find the minimum moves to make array complementary. Okay, so we have to find the minimum moves. Okay, what we have to find? The minimum moves we have to find. Okay guys, so that the so we have to find the minimum moves to make the array. So we have to make the array, right, complementary. Okay, what is the meaning of complementary? It is saying that a array nums is complementary if all the indices, right, all the indices I is zero index. Zero index means what? The array that we have given is start from zero index onwards, like this. Okay, so if we'll say nums at I plus nums at I, so nums at nums at n minus 1 minus I. Okay, so let's understand. So nums I is 0. For instance, let's suppose we have element 1 2 4 3, right? 1 4 3 we have, right? 1 2 4 3, like these elements we have, and in this case I is 0. So nums, what will happen? Nums at I is 0 plus what is the length we have is 4. 0 1 2 3 4 means how many elements is 4 element. So again we'll find nums at 4 minus 1 minus 0, which comes nums 3. What is at nums 3? Nums at is 3, this one. So if we will do the sum, right, so we'll find nums at 0 is 1 plus 3, right? How much you will get? You will get 4, right? So it is saying that the array nums is complementary if all the indices I indexed nums at I plus nums at I minus 1 equals the same number, right? Equals the same number. Understanding or not? So if this value equals the same numbers, right? For example, the array we have 1 2 3 4 is complementary because of the indices I, where we find nums at I minus 1 is equal to 5. Understand? So this is why we'll say the array is complementary. Okay, so we have to return the minimum number of moves required to make this array complementary. The very first thing what we have given is, we have given nums, we have given, and one element we have given is limit. So limit we have given, in one move you can replace any integer from nums with another integer 1, right? And between 1 and limit, it means, so let's suppose for this value, what will happen? Now you will change this array in another array, right? The very first, when I equal to 0, you have changed the element to 4, right? Similarly, we'll calculate other elements. So let's suppose we have given this 4 4 4 4, like this we have given. So this element become 4 4 4 for all, right? So you can replace the integer between 1 and the given element. Okay, for example, nums at I and this equal to 4 for every I. So nums is complementary. Got it? So if you have any doubt, you can ask me in the comment box, right? If the question you have not understand. Let's understand how will you solve this problem. Okay, so let's understand how to solve the problem, right? Basically, I told you that this problem contains two things. One, what we have given is, we have given two things. The very first thing we have given is an array, right? We have given an array that is called nums, right? And another we have given is an integer, and that is limit, right? Two things we have given, nums we have given and limit we have given, right? And what it is saying that if B pair elements, if B pair elements, let's suppose nums at some value will have 0 with nums at n minus 1 minus I is already 0, so it will become like this, right? So the very first pair is like this, right? Let's talk about the second pair. Second pair is nums at 1. It means the element become what? Nums at n minus 1 minus 1 is n minus 2, correct? And will go so on, right guys? Correct. So there is a pair, right, which is complementary, right? What the question saying that a pair is complementary if 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 we have this pair nums at I, right? That we have seen for 0, we have seen, and for 1 we have seen, right? For 0 we have seen, and for 1 we have seen, right? So what it is saying that nums at I plus, if we'll do nums at n minus 1 minus I, right? If these two pair gives the result equal to what? Same value for all these pair, for all pairs, we can say. So we know that these are our pairs, these are, we have pairs, right? And if I'll say nums at this I plus nums at n minus I, n minus 1 minus I is equal to same value we have, then you can change any number to any value between 1 to the limit, right? What it is saying that? It is saying you can change any number to any value between, right, 1 and limit, right? In one move. Make sure that per move we have to do. We will have many moves, but we have to find the minimum moves we have to find. It means if I'll talk about what is our goal, right? Our goal is to minimize or find minimum total moves, right? To make all pairs have the same sum. Gotcha? Easy, right? So we have to find all the pairs have the same sum. Now think. Okay, let's think little interesting we have here. So what we need to do is for each pair, let's suppose we have A and B we have. So two elements we have A and B. So let's suppose we'll say, okay, what is current sum? We'll say current sum is A plus B, right? Means what we want, that we want all pairs to end up with some target, we can say some target, right? Target sum S, we can say that. So each pair has different cost, right? So we'll say, okay, here each pair has different costs, can I say? And that depends on what? It depending on S, right? Can we say that? We can say that, right? So for every pair, correct, let's suppose current sum is a plus b, we want all the pairs to end up with some target sum s. So each pair has different cost depending on s, right? So what we will say, okay, let's go with some pairs, right? So we'll say, okay, now think like it's very important, okay? So I'll say for a pair, we have a pair, and this pair contains a and b, two things we contains, okay? So for pair A and B, I'll say I will have some move, right? So the moves start from 0, let's suppose, and there are some condition. So we'll say, okay, what is the condition we have? So we have condition, and the condition is, let's suppose, if we'll say S equal to A plus B, will say, right? So we have condition S equal to A plus B. When we'll say we have move 1. So the move, if we'll say if S is if S can be formed by changing one element, right? Then we'll say, okay, next move in otherwise, right? Like this we'll say. So we have such a way that for every pairs we find the current sum, right? For every pair, we find the current sum, and we want all pairs to end up with the some target value s, right? And each pair has a different cost, which is depending on s. So we'll say, okay, for this pair, we have some moves. Moves are 0 if s is equal to a plus b, if move is move to 0 to 1, if s can be formed by changing some one element, or we'll move to the next move in other cases, otherwise cases, right? So like this, we'll keep finding for each pairs. We are talking about for each pairs, not for all, not for the entire array, right? For each pair. But that is, if you see, we have go for all the pairs again and again. So there is a efficient strategy, right? So what is the efficient strategy? Okay, if any spelling mistake, don't mind, okay? So efficient strategy is that we will use a difference array. If you remember, there is a pattern that gives you an idea. So instead of checking s separately, which gives you too slow, right? Because we have to find for all the pairs, right? We are talking about for all the pairs. So if you have only one pair, so you have to do this. But if you see, a simple array contains many pairs, right? There can be a entire many pairs will be there, right? So what we need to do is to do this activity for one pairs or many pairs, right? It become very slow. So what we need to do is you go with the efficient strategy that gives you a way that you can use a difference array, right? So instead of checking each pairs as separately, that gives you a too slow time complexity, right? We should use a difference array. So difference array we will use to track the cost is changing, right? And then if all the possible sums we will find, right? So we'll say, okay, what is the sum contains, right? Sum belongs to what? So what I'm trying to say is, let's suppose the very first thing, why we will use, because it's too slow, the above approach is too slow, right? So we will use difference array to track what we want to track, to track the cost that is changing, right? If cost is changing, so we have to track that. Then we'll sweep all possible sums. We'll find the all possible sums, we can say, let's say s, right? Which should be between the, let's suppose 2 and 2 into limit, like this, okay? So that we have to do, right? So we will not go for like all the pairs, right? We'll do the finding the pairs moves, right? But we will use this approach where we will use the difference array, right? And we'll track the cost first, then we'll swap all the sums, right? That we will do. So what we are trying to say here is, let's understand. Okay, so let's suppose that for each pairs, right? Let's try to understand again. For each pair you have a and b, right? We know that for each pair we have a and b, right? So we'll say, okay, let's take low and call this minimum between a and b. If this is minimum between a and b, right? So we'll say, okay, put, you have taken low at a mean of a and b, so take a high also. Okay, so high will be at max value and max will be a and b, which was the max and b, right? So we update the ranges. How will update the ranges? So we update the range, right? How will update the range? Let's understand. The very first thing is, there will be a default cost. Okay, and the default cost is equal to give you 2 moves. Okay, then we'll say, okay, the difference array at 2, let's put with 2 but keep adding the value, right? Then what we need to do, we'll say, okay, now difference array 2 into difference array at 2 into limit, we will say similarly, right? And we'll do +1, okay, which should be equal to 2, but this time we will subtract, right? Because we know the default cost is 2 moves, right? That is why we have to do. Okay, then in step 2, what we need to do, we know that we have the cost that can be reduced. Okay, reduce to 1, reduce to 1, we will say. Okay, the very first default cost is equal to 2 moves, so we'll do these things. If cost can be reduced to 1 or not, so we'll say, okay, let's understand if s is in n, we can say, okay, s is in the range we have found. What we have found is low and high, right? So we'll say, if we have low, then we'll say low +1 between, and you find the high plus the limit. So you'll find low +1 and high plus limit. Between that, we will check if s is in this range, right? So in this case, what we will happen, guys, we'll say, okay, now what is the difference array will have? So difference array at low +1, we will update equal to, with minus we will update. Give me 1 second. Equal to 1, will say like this. Okay, and the difference array at, there will be high plus limit, right? So we'll say, okay, in this case it will become plus equal to 1, because we have reduced to, the cost has been reduced to 1, right? Now there is one more point we will focus at. Cost is 0. So at, we'll say, if sum is a plus b, right? In this case, what will happen? We'll say, okay, the difference array is a plus b minus equal to 1, but difference array at a plus b plus 1 should be plus equal to 1. So we have to check what will happen in all these cases, right? So we will update the range. If default cost will say 2 moves, cost can be reduced to 1 or not, and cost is 0. So these three things we have to think. It means if I'll say, okay, let's talk about the how will you find the how will use the prefix sum over the difference, right? So basically we'll say we want to compute a prefix sum, right, over difference array to get what? To get the cost at S, we will say, is total moves needed if target sum equal to S less, suppose. Like this we will say. It will return what? Mean of cost S. Like this. Okay? And this is your final step. I hope you understand. Let's recap, okay? The very first we started with the thing that what we have is what we have given. We have given nums and limit we have given. Then we know that we have a pair of elements, right? So we'll say nums at 0 and nums at n minus 1 minus I, right? So we'll find these pairs, right? So all these are the pairs. So we'll say the pair is complementary if we'll find the sum, right, of the pair, and it gives you the same value for all these pairs, right? And you can change any number to any value between 1 to the limit in a move, right, in one move. So our goal is to find the minimum move so we can make all the pair have the same sum, correct? So for each pair, right, for A and B, what we can do is we'll find some equivalent sum is A plus B. So we want all the pairs to end up with some total target, and each pair has a different cost depending on S. So we'll say, okay, so how we'll find the moves? So we'll say, okay, in move 0, right, initially we'll say if S equal to A plus B. Oh, fine, let's move to one next move, right? We'll say, okay, if S can be formed by changing one element, otherwise we'll say, okay, go for the otherwise cases, and these type of moves will increase. But we have a strong efficient strategy where we will not go for like all the pairs again this approach, right? So better what you need to do is find the difference array where you will track the cost what is changing and swap all the possible sums and between 2 and 2 into limits, right? So we'll say, okay, for each pair what you need to do is take low and high, two things, right, and update the range. How will update the ranges, right? Let's suppose the default cost when you have two moves, right, you will update like this. If you have if the cost can be reduced to 1 or not, so then you will apply this, right? If cost is 0, then what we will do, we'll say, okay, check S equal to A plus B, like this, right? So we want to compute the prefix sum over the difference array, okay, to get the total moves needed if the target is S, and just you will return the sum. Let's understand how to do that. So let me recap, right, little bit so you will understand. Okay, the very first thing is, instead of what is the intuition we are talking about, right? So basically the instead of fixing a target sum, right? So we are not going to fix the target sum, right? So what we will do, so instead of fixing the target sum and recalculating the cost, right, repeatedly, okay, check the repeatedly, okay. So instead of fixing a target sum and calculate the cost repeatedly, what we can do is the very first will be pre-compute how each pair of. So what I'm trying to say is instead of fixing the target, right? Instead of fixing the target sum, what we need to do, and recalculating the cost, right? We should do what? We should pre-compute what? How much each pair affect sum. Okay, then use prefix sum target, right? If we'll do this, and this will give you the efficient way. So do not fix the target sum, because you need to recalculate again the cost, right? So basically you pre-compute how much each pair affect all the sums, right? And then use the prefix sum to aggregate those values, right, efficiently, and it will give you the final results. Okay, I'll show you how. Okay, so the very first thing is you should start with, right, the difference array, right? Then you know that if I 0 to n minus 2 we will go, right, we can find almost the half of the pair, because we know that half of the element will live here and half of the element will live here. So you start with 0 and go to n minus 2, means you will find a from here, b from here, if then the one, then the second last, like that you will find all the pairs. Okay, so that you need to go with this loop. Once you will find a and b, right, from a from this side and b from this side, right, then you will set the low and high. Then you have initially have to assume that 2 moves we have for every possible, so that we need to do, and then we'll update the range where we have only 1 move is needed. In that case we will do. Then we'll find if the sum gives you exact 0. So all these 3 cases that we have talked about, then we will check and we'll apply these things. Okay, finally we have to find the answer. To find the answer, let's suppose that we have the prefix sum which is already pre-computed. So you just need to calculate the minimum moves. So you'll start with s equal to 2, you'll go with 2 into the limit, and you will find the current, and you will find what is the minimum, and you will, once you will find the minimum, right, you will update the minimum, you will return the minimum finally, because you are traversing over the entire sums, right, and you will find the minimum, and that once you will find the minimum, you will return the sum. So this is what we have in this video, guys. In case you have any doubt, you can ask me in the comment box. Thank you so much. Bye bye, see you tomorrow.
Thank you guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.